morning. Welcome to Power Hour, Easy Motion over Ethernet IP. I'm Bob Pillen, Electro-Matic Motion Specialist. I got my contact information down the bottom left-hand corner. We also have AJ, who's one of our tech support people, and that will help with some of the demonstration. So this hour, we're going to do a brief product introduction to some of the drives that will play well in Ethernet IP. And then we will also give AJ is going to give us a live demonstration.
My name is Andrew Jorgensen. I'm an application engineer with Electro-Matic. I've been with Electro-Matic for about 10 years now. What we're going to take a quick look at is how to control a G120 drive over Ethernet IP with a compact Logix. The same logic is true for control Logix or really any Rockwell processor. But first thing I want to take a look at is application note from Siemens. What we're looking at here, there are three separate blocks from Siemens to control the drive. The first one we're going to be, or the only one we're going to be looking at today, is the speed control block, since that's most relevant for G120 as it's a normal VFD. Taking a look through the manual, you'll see it will walk you through the entire setup of the drive. It will walk you through the entire setup on the Rockwell side, importing the AOI, EDS files, logic, all of that. And there are also some HMI faceplates in here, which we're not going to go through. I'm not going to click through the whole manual here, but you can see from the contents that it will take you through the whole thing. If you forget anything I go through today. So first things first, we need to actually commission the drive. So we need to add the device to our portal project. In this case, we have a G120. There's a CU240E-2PNF. And it's version 4.7.9. You can verify the firmware version using either the Online and Diagnostics tab in Portal, or if you have an operator panel on the drive, you can verify on there in the Extras tab. We're going to add this. We need to configure our power module. The power module we have here is a PM340, since we're on 240 volts. I'm going to go ahead and go online with the drive. There we go. All right. Now we need to go through the basic commissioning here. So we're going to step through the commissioning wizard. Our options here are standard drive control or dynamic drive control. For most applications, we're going to select standard here. This selection is where the ramp function is being calculated. We're going to let the drive calculate it and just have the PLC send it speeds and directions and whatnot. This is where we select where the set point is coming from. If we were using local I/O, we can do that. Otherwise, we're going to use the field bus, which in this case will be Ethernet IP. So we're always going to choose 7 here if we're taking the set point over the network, either with Profinet or Ethernet IP. And we select our standard telegram. For applications where you're doing speed and direction, telegram 1 is usually what you're going to pick if you don't need any extra information. I've already gone through and entered the motor information just to save us some time here. But as we tab through all of this, we'd be entering line voltage, we'd be entering all the nameplate information off the motor, which I've already done. There is no holding brake. These are the reference speeds. So the reference speed will be important. It's good to note this or write it down somewhere if you think you're going to forget it. We need to enter this into the AOI on the Rockwell side. So it's good to make sure you remember what this is, so we don't always have to go back and check. Finish. Okay. And by default, when you select mode 7 for set point over field bus, the drive is going to default to Profinet because it's a Siemens drive. So we need to go pick Ethernet IP. It's parameter 2030. It's right here. I've already set it so we don't have to deal with power cycling, but what you're going to do is select Ethernet IP, then come into commissioning, saving and reset, save the RAM data EEPROM, so that backs the RAM of the drive up to the non-volatile memory and backs up your parameter changes, and then you'll power cycle the drive. Now, we've already done all this to save us some time here, but okay. And that's it on the drive. You'll see the drive is still red because we have not configured the Rockwell side. So let's go ahead and do that now. That's all we have to do on the drive side. Let's come over to the Rockwell program here. First thing we need to do is install the EDS file. That'll tell it how to communicate to the drive. This file is available from the website I showed you right when we got started here. I will share a link to that in the chat of this meeting so everybody can take it and bookmark it if they want to. So we're going to click in a little further. Because we set the drive up for Telegram 1, we're going to select Telegram 1, PLC EDS files, and select the Siemens G drive EDS. Open, next. next, and finish. Okay. And now we're going to add a new device. New module. Click Siemens Telegram 1 and create. And put in the IP address. 5. We do need to change the keying and the data layout here. By default, it does not disable the electronic keying. We need to do that. And we need to change the data layout from SINT to INT. Hit OK. Yes, we want to change the module definition. OK, and close. All right. So now we have the drive. Next thing we need to do is add the AOI. So we're going to import the AOI from the same folder. Same folder, Telegram 1, PLC, AOI. And we want the AOI Telegram L5X. This AOI is if you're using the HMI faceplate that comes with this library. We're not going to do that today. Go ahead and import the AOI here. Next thing we need to do is pop back out onto our main routine or wherever we want to be controlling the drive from and bring our AOI in. I've already written some of the logic to save you guys the boredom of watching basic ladder logic being written, but this is the general enable for the drive. So generally speaking, what we'll do is leave this drive control enable always on and use the run command to turn the drive on and off. The main set point, this is where we're sending in an RPM to the drive. So we need to set up the tags for our AOI here. Okay. It's supposed to be the input. You need to grab our actual data from the drive. Type in that reference speed, 1650. Okay, and this is our speed coming back. I apparently named the drive something different this time. Okay, now we're good. We're going to go ahead and go online. We're going to download this to the controller. Okay. Now, to over here. All right.
So now AJ's done the commission and integration. What is going on my computer? There we go. Now we can take a look at Siemens' comprehensive drive portfolio and how they are easily integrated into this Ethernet IP network. And thanks, AJ, gave us a nice demonstration on how that works. This be somewhat of a quick overview. So if you have any questions or like more information, my contact information is down in the left-hand corner of the screen. You guys can copy that down right now if you'd like. Okay. So Siemens has a comprehensive line of products with flexibility to communicate with the Rockwell controllers and integrate into the Ethernet IP networks. Anywhere from network and switches, distributed I/O, HMI hardware and software, RFID and drives to cabling. We can communicate with the entire system. These products are easily integrated with a catalog of instructions supported by Siemens Electro-Matic, as AJ kind of pointed out, and I think AJ said he was going to share a link to those as well. As you evaluate your existing system or new product topologies, Siemens products can be integrated one component at a time, a combination of components, or the entire system without changing the PLC. But today we'll focus on the drives. Siemens drive families is Synamics, and Synamics drive family is the most flexible and efficient and comprehensive drive solution. They have a large breadth of product with a large with the flexible interface options. With direct network connectivity to Profinet and Ethernet IP, they have standard Ethernet TCP/IP. Synamics is a pretty flexible product that can fit within your plant network or your next new machine. The following Synamics drives are the Ethernet IP connectivity, fit comfortably with an Ethernet network. We have the general performance drives. We have the G120. This is a modular concept. We have the G120C, which is a compact, cost-effective general performance drive. We also have distributed drives. We have the G1. Let's see if we get presenter mode here. There we go. So we also have the distributed drives. We have the G120D and the G115D. These are IP65 that can be mounted right on the machine. We have a new product, the G120X. That's really designed for infrastructure, HVAC fans and pumps and compressors. And then a higher horsepower, the G130X is a kind of a chassis type in-cabinet mount solution. From there, we have our high performance and servo drives. We have the S120. We have the S120M, which is a distributed IP67 solution. We also have cabinet modules, the general performance cabinet modules, and we also have high performance cabinet modules. We'll take a quick look at those. And yes, Siemens brought their DC drives up to the new platform with Ethernet IP as well. So let's take a look at some of the advantages of the Siemens solution. We have one complete integrated drive family. It's like a consistent platform, consistent configuration. Parameter numbers are the same across the board. So if you know the FLA drive parameter in one drive, you'll know it in the other. That makes it very, very convenient when using a multiple drive solutions from Siemens. The broadest range of customized solutions. You get the perfect drive, for the drive system for your specific application. We have advanced engineering tools from choosing the best drive, getting started faster, making changes, diagnostics to run more efficiently. The most options for automated integration. We already talked about Profinet, Profibus, Ethernet IP. So pretty much every other industrial communication system. The ultimate and motor drive integration. Siemens drives and motors talk to each other. So when you set up a system, you connect to it, you say, tell me what's out there. It configures itself. And it also has an advanced motor tuning feature that will tune induction motors, third-party motors, very tightly to the drive. They all have a common goal of energy efficiency for each drive, and safety integrated into most products. Not only safety integrated, but network safety, and very easy to set up. So here's a snapshot of our general performance drives and their horsepower. The G120, the modular design, is ranges from 0.5 to 400 horsepower, and it can sit on a 230, 480, 690 volt. And it has different control options to right size your functionality to your system. We have the G120C, which is the economical, compact, and space saving version of the G120. The range is 175 to 200 to 0.75 to 25 horsepower, and it sets on the 380 to 480 volt bus. This system is one part number for the control unit and the power module. It's all integrated together. We have the G120D and also G115D, which is a closed loop, which are distributed I/O. The G120D is our closed loop vector drive. It comes with positioning, 1 to 10 horsepower. That's the 380, 40 volt bus as well. We also have our G120 product that is built into a cabinet. We call that the G120E. They have a number of flexible options for that as well. We supply those with a 100, 200 horsepower range. The G130, which is the higher power cabinet module that's designed to go inside of a cabinet, 150 to 800 horsepower. That is a 380, 40, and a 600 volt line component. And then G150, which is our enclosed air or water cooled variable speed drive with line, and that's 150 to 800 horsepower. Now we have our high performance servo drives. We have the S120s. That really kind of is our flagship so far. We're slowly migrating into other products, but this is still our new platform, our S120. It's a modular high performance drive system. It can do vector, open loop, closed loop vector, servo, volts per hertz, single or multi-axis applications. It can run anywhere from an induction motor to a linear motor to torquer motors. The range here is 0.25 to 1250 horsepower, but we'll talk about that a little bit later. This can also run on a 230, 480, and 690 volt systems. We have different formats: book size, block size, chassis, and cabinet, which we'll talk about as well. We have the S150. That is our cabinet, our air-cooled AC version of it. It's a big cabinet, 150 to 1250 horsepower as well. This can do line regen as well. And then, as we talked about, we have our big DC master. It's our DC drives. We still have a lot of applications where it's not cost effective to change out those big DC motors, and so we brought that up on the new platform with all the advantages of our other drives. It's 5 horsepower to 24,000 horsepower, 85 to 950 volts. So here's a quick look at our G120C. This is our compact version. It has this is one part number. It's got the power module, AC in, AC out. The control unit is built in. This interface module is separate. This is designed for pumps, fans, compressors. This is a very versatile drive. And material handling, conveyors, mixers, extruders. It can do volts per hertz. It can do modified volts per hertz. It also can do open loop vector. And then our next step is the G120. This is a modular design. I think it's very popular in automotive just from the maintenance and spare parts consideration. We have the AC to AC unit. There's a PM240. So this is AC in, AC out. This is just the power block, if you want to call it that. You have the control unit that you order separately with different control units that we talked about. That's can be flexible in many different applications or control schemes. These interface modules are the same across the board for the G120 series. So what's nice about this is the actual control unit. So all the parameters and setup is all, and the wiring is all on this control unit. So in a maintenance situation, if the power module, which is, you know, get struck by lightning, this is probably the most susceptible component for damage. Click this off, change this out, and click that back on. And from a spare part standpoint, you can stock many one part for many different applications and have different control units. This is our G130 and our G150. This is our cabinet module, the G130. This is for higher horsepower. These are designed to go in the cabinet. And Siemens has done that for you as well, and they call that the G150. And these are all built down in New Kensington. Some are built in Germany if needed, but these are out of our New Kensington office in Pennsylvania. This is designed to be, it has an AOP30 on it. This is a interface module. It's very flexible diagnostics running just like our advanced, but it has a larger screen. They are also compatible with some of our other commissioning tools, which I'll show you in a little bit here. Then in our distributed drives, we have the G115D. That's a relatively new product for us. And Siemens is really, really focused on out of the box functionality. We've seen that in this G115D. We're seeing it in the G120X. So you order a 5 horsepower G115D. It is compatible with a 5 horsepower motor. So from an integration standpoint, startup standpoint, it saves money. Everything's pre-commit, saves time and money. It's pre-commission. There's a modular construction concept. You have like the electronic module and you have the wiring module. That makes it for ease of installation, ease of troubleshooting, ease of maintenance. It's fully integrated into our TIA portal start drive, which you saw a little bit of what AJ demonstrated, and we'll talk about that as well. A web server with a smart access module. We'll talk about the smart access module. It can be mounted, on the conduit box of the motor. It can be mounted on a wall mount. It has our safety STO, and then it's compatible with Mind Connect portfolio as we start moving into digitalization based analytics. Even from the connectorization, they have a plug-in connector system or GLAN cable, whatever fits your needs, and for ease of integration. This gives you an idea of how it fits into a topology and some of the options. As you see, you have the G115. This one's mounted on the conduit box. This is separately. We have our interface with our Wi-Fi, if you do choose so. Profinet Ethernet IP up to a Siemens or Rockwell PLC and direct connect to the HMI. We also have some commissioning tools that help for fully for ease of integration and also diagnostics. G120D, I like to call this our Cadillac of distributed drives. You can tell it's safety. It has that nice yellow headband on. A lot of Siemens products will put a nice yellow headband to depict that it's it has safety on board. This is another modular design. You have the power module here, and you have the control unit here. This control unit unbolts, pops off. If anything should happen from a power standpoint, you have all your connections, all your parameters right on this control unit. Although I've mentioned that on a couple of products, we do have options for backing up parameters. We'll go over other options for backing up parameters as well. This unit is IP65. It can be mounted in harsh environment. It has open loop, closed loop vector. It can do positioning. It does line regen. So this is really a full functioning a general purpose distributed drive. And then the G120X. This is another relatively new product, not real new, but a relatively new product for Siemens. It is really designed for the infrastructure industry, although we've used it in a lot of other different industries, but it's designed for pumps, fans, compressors, the HVAC, municipal stuff. It ranges from 1 to 700 horsepower, and look at the voltage range: 240, 480, 690. So it covers a large breadth of voltage ranges. It has enhanced features for the wastewater and HVAC market. So that's one of the things Siemens does as well is that they cue the market and they pull the market and design functionality around what what the market demands or would like. And this is another product that is out of the box concept. Fast, easy setup. 10 horsepower motor, 10 horsepower drive. You plug it in and you go. This is Siemens Seymour gear product line. It's a gear motor. It's really it's a real flexible product. It's designed to mount up to most of the standards out there for easy replacement. There's another product, the G110M, that could be mounted on the conduit box as well. That could be mounted on a wall. The G110M is also Ethernet IP, Profinet. It doesn't do line regen. This is really a standard, I don't say a low end, but because it has a lot of functionality with open loop vector and volts per hertz. But as far as compared to the other products, it's a lower end, cost effective distributed drive. Excuse me. And now for the higher performance drive systems. This is the S120 book size. Siemens has done some modifications as again, like I said, they listen to the market and they listen to the customers and they make alterations as they go. But this is a modular system. This is a very flexible system. It has it's a common bus. So this is the in-feed module. It takes AC in, converts it to DC, and through these bus bars, it brings the DC bus and the power to the inverters. Also has a 24-volt bus. So, and these bus bars you can take them off, but it's not necessary. You just loosen them up and they kind of flip out of the way. These unplug. So it's a modular approach. It's very easy to integrate. And then you have the control unit, which is a very interesting concept. But the microprocessors being so quick, Siemens was able to condense 6 drives into one control unit. So this can operate up to 6 motors. I say 6 drives, but I'll say 6 motors because Siemens has the options of having a dual axis motor module. These dual axis motor modules can run 2 motors independently. One can be in safe torque off, and one can be fully functional. You can pop an IGBT in one of the motor modules. It'll be fully flexible depending on how you run your machine. And you have single axis modules. But one of the alterations Siemens did is they actually brought the connectorization up for the motor, so it's easily obtainable. Sometimes these are easily accessible. Some of these drive systems are mounted down towards the bottom of the cabinet. This control unit here, this is where all the brains are. If something would happen again from a power situation, whether it's the motor module or the infi module, you can change out one of these components, not the whole drive system, and all your parameters, all your setup, all your programming is kept inside this unit here as well. And this guy here can be mounted for up to about 100 meters away because it's just a network cable for arc flash considerations. So Siemens has really taken a hard look at the industry and really made their system really flexible. This is the AC to AC version of it. This PM240, that's something Siemens did, I think was probably 5 years ago, maybe longer. One power module is utilized for the G series, which is general purpose drives, or the S series, which is our systems drives, higher performance. So this power module is the same thing we saw back at the G120s modular system. But you click on CU310, now you have a fully functional S120 with the same functionality as the CU320s. Then we have the distributed high performance servos. This topology is very similar. You had this CU320. This is the NFI module. So the ACN common bus. And then you have an adapter module. The motor modules now are on the back of the motor. So this adapter module takes our drive click as our it's an Ethernet based media, but it's a drive click protocol. It's like kind of our backplane to communicate from module to module, drive to drive, motor to motor. So it takes that protocol, the 24 volts, the DC bus, and condense it to one cable. And from there, you can daisy chain from motor to motor. So like end effectors to a more distributed design where you don't want to run cables back and forth. This is a very flexible system. So we want to talk about some of the interface options, some of the diagnostic tools that Siemens has developed for our drive system. For the general performance drives, they developed a couple of different operator panels. They have a basic operator panel here, and then they have an advanced operator panel. They both can upload and download parameters to them for cloning or backing up a drive. They have diagnostics. This will come up with some limited diagnostics as far as a description. It'll have, the fault number. You can parameterize the drive. You can run the drive. This is the same, except for you have, as you can tell, the screen is much better. It has better diagnostics, better descriptions, more capacity for upload and download. These two click right on the front of the drive here. This can be connected through a cable with the drive. This is a kind of a remote pendant, so you can walk from drive to drive. And I can't remember the numbers, but if you guys are interested, I can tell you how many sets of drive parameters can be stored on each. And then we have the SAM, Smart Access Module. I'm typically, I like the plug in the computer. I like plugging in the interface modules. But when I use this quickly became my favorite. You have a Wi-Fi module that clicks on the front of it, just like the interface module. And then from a tablet, PC or phone, you can actually do the same functionality as you do with the interface modules. You can run the motor, you can tune the motor, you can parameterize the motor, diagnostics, backup and restore through the cloud, monitoring with different parts of the drive control. What I like about the diagnostics, it has a very good description of each of the faults, and then if you get into a situation that a fault that you don't understand, you can click and you can email that right to AJ, right from your phone. AJ will get it immediately, or text it to him, and then he can help you out directly. So very versatile. This is probably by far my favorite. The S120 cabinet module, kind of saved this one for last because we talked about 1250 horsepower. This is another system that's built here locally in New Kensington. This system has an infeed section that can be paralleled with many different infeeds. You can do multiple motors, or for the very high horsepower, like for instance, we have 2,000 horsepower motor we started up about a year ago. It was really a couple infeeds, a couple motor modules, and one motor. So it's very flexible. 6,000 horsepower is not something that's out of the ordinary. It's out of the ordinary for me, but not for Siemens. So these are, and they'll do customs as well. I think I had a slide out of whack there, but so this is one of the diagnostic tools and commissioning tools, and it's Start Drive from Portal. You saw a little bit of what AJ was doing, but it by far captures the complete functionality of this software. First and foremost, that TIA Portal is something that we use from a Siemens standpoint to parameterize and program our PLC system. We also use it for our drives, so everything's integrated into one software. But from a drive standpoint, commissioning parameterization is very easy to read. You have graphical representations, and then on another tab, you quickly click over, sorry, and you get the expert list. I don't know if everybody's seen any expert lists. They can go from 0 to 20,000 parameters. What Siemens has done is when you're in that graphical screen, they have the parameters that are related to that graphical screen. You certainly can look at all the parameters, but they've really made it easy to go back from graphical to its expert list. On top of that, running the drive, you have a online toolbox to run the drive. Then you can switch over to run it from the PLC as well, the technology objects in the PLCs, all in the same software. The diagnostic has trace functions that you can trace pretty much any of the parameter I/O from the drive, stuff coming over from the telegrams. You can chart those as well. So from a diagnostic standpoint, this is probably one of the best softwares I've seen. I'll try to wrap it up here real quick. So we'll go over some of the quick. I'll just give you a nice splash of the safety features. Most at least all the drives that we pretty much talked about has the safe torque off, which is becoming very popular, very almost a standard in the industry. That can be done either hardwired in most drives and Profinet for sure. ProfiSafe over a safety network. Safe Stop 1. It's a version of Safe Torque Off. It has a built-in delay, so it allows the motor to decel to a stop before it becomes enters in a Safe Torque Off. So I'm not sure if if you guys are familiar with all these safety features. We have everything. Then we have the more the advanced ones with safe speed monitoring, where you can run the safe limited speed, where you can run a system under a certain limit while you're feeding parts or troubleshoot or diagnostic or setting up, and safe safe position as well. So they have a very, very large breadth of safety features built into a lot of the drives. And this is where it was originally going to be a lead into AJ. This is it shows you the telegram setup, which AJ went over, and some of the speed blocks. There's some of the add-on instructions. This happens to be a speed block. So that's all she wrote. One of the things I wanted to put back up here is we covered things pretty quickly. It's very difficult to go into any details with the breadth of product that Siemens has. So there's my name again, Bob Pillen, Electro-Matic motion specialist. There's my address, and don't forget the 2 P's, and then my phone number. So feel free to reach out to me. I'm not sure if we're gonna if we want to field some questions now. We certainly have 5 minutes. We can do that. All right. Well, maybe we'll just take the questions offline. If you have any, feel free to reach out. Thank you. Appreciate your guys' time and patience. You guys have a good afternoon.
Just a quick note before everybody drops off. Everything will be posted to our website. Bob's presentation, links, recording of the presentation and whatnot will all be on our website sometime soon.